everybody, and welcome to your Maths with me today on this Thursday. So what we're going to do is we're going to carry on with our learning that we've been doing all this week. So we're going to be keeping our focus on improper fractions and mixed numbers. Okay, so hopefully you have knowledge on what those are. So let's have a little look then. So what I've done for this morning is I want you to show you a little bit of a real life situation where you might be using these improper fractions. So my question for you then is a little bit of a word problem, so you might have to pick out some key information. So Mr. Armstrong has had a disaster in the kitchen this morning. He cut all of the children's bagels in half, but he's forgotten how many bagels he has done. He has 75 holes. So how many whole bagels has he got? Okay, because he cuts them all in half, because remember we eat them in halves, but now he's forgotten how many bagels he was on. So can you help Mr. Armstrong out there? And can you think how many whole bagels has he got? Once you've done that, if you want to then challenge your brain a little further, there's an extra little step of this question. So for the FS children, he's got 8 bagels. He needs 34 quarters to feed all of the children in FS. Will he have enough bagels? If no, how many more bagels will he need? So 2 little questions for you there. So you need to think about those key information. So improper fraction, mixed numbers. So have I got my improper fraction and I need to convert it to a mixed number, or have I got a mixed number or a number that I need to convert into an improper fraction? So have a think, which way round am I having to do this? And then you need to add some extra steps in there. So first thing I want you to do is, what problems are you solving here? And I want you to think about the steps that you're going to have to take to solve this problem. Have a little pause and have a little go. See if we can help Mr. Armstrong, because he's got a little bit confused. Wonderful. So hopefully you've had a little go at that now. If you haven't, just pause me and make sure you have a go at getting an answer before you hear me trying to tell you how we're going to work this out. Okay, so the first thing we need to do is we need to pick out the key information. So we know that Mr. Armstrong has had a bit of a disaster. He's doing the bagels and he's cut them in half. So I'm going to take that as a key bit of information. Okay, he's cut all the bagels in half. He's forgotten how many bagels he's done. He's got 75 halves. So actually, do I need that half information? No, I do need the denominator because I know that I'm working with halves. But how many halves does he have? How many halves does he have? It says he has 75 of those halves. So straight away there, my top number is greater than my bottom number. So I know that this is an improper fraction. Okay. How many whole bagels has he got? Okay, so now I'm converting this into a whole. So I want to think about the wholes and the parts that he's got. So I'm going to be converting this into a mixed number. Okay, so well done to you if you worked out that we were converting our improper fraction into mixed numbers, because I want to see how many wholes that I've made with those 75 halves. Okay, so first thing I need to do then, so how many parts make my whole of a bagel? I know that 2 parts will make 1 whole bagel. That's my key bit of information that I've got here. Okay, so 2 parts will make those whole bagels. But I've now got 75 parts. So how many groups of 2 can I make using 75? So what am I going to have to do there? What number says? So I could use my 2 times table and count all the way up to 75. Is there a quicker way that I could do this? I'm going to use my knowledge of inverse, because I know that 75, if I divide it by 2, if I put it into groups of 2, I will then see how many lots of 2 I can make. So how many lots of 2 can I make from my 7 tens? 1, 2, 3, 4, 5, 6, 7. So I can make 1 group of 2, 2 groups of 2, 3 groups of 2. And I'm going to have 1 10 left over. So that's going to go over there. 10 ones. So now instead of 5 ones, I've got 15 ones. I've got 15 ones. So how many groups of 2 can I make from 15? Again, I can draw them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, 5 groups of 2, 6 groups of 2, 7 groups of 2 with 1. Okay, so how many whole bagels can I make putting those halves together? I can make 37 whole bagels, and then I've got a half. I've got 1 half that's left over. So I think Mr. Armstrong's had a bit of a nightmare here. I think he might have lost one of his halves, because actually he's only got 37 and a half bagels. So well done to you. If you got that correct, 37 and a half is how many bagels Mr. Armstrong has got through. He needs to find that other half. Maybe it's rolled underneath the counter or the oven. It doesn't. I do that all the time. So well done to you if you got that right. So let's have a look at this FS question now then. So I know that Mr. Armstrong has got 8. Now I'm going to draw this to help me understand this question. He's got 8. That's only 6. 8 bagels. Okay, so we've got 8 bagels, and for the FS children, he cuts them into quarters. So I'm going to cut my bagels into quarters. Okay, so I'm using a drawing here. So whichever way you did this, it's absolutely fine. He needs 34 quarters. Or letter there. He needs 34 quarters to feed all the children in FS. Okay. Will he have enough bagels? If no, how many more bagels will he need? So I've got my 8 bagels here, and I've cut them into quarters because that's what Mr. Armstrong will have to do. So let's see how many quarters he has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I have 32 quarters. Now, as I was doing that, I just thought of a really quick, I'm going to put my evaluator glasses on. I just thought of a really quick way that I could have worked this out. I've got 8 bagels, and each bagel is going to be cut into 4 pieces. So I've got 8 lots of 4, which we know 8 times 4 is 32. Silly Miss Tyson, that was a much quicker way. Why didn't I just think of that first? So I know that I've got 32 quarters. Is that going to be enough to feed all of the children in FS? No. So how many more bagels is he going to need? Well, I can see that I've got 32 pieces, and I actually need 2 more quarters. So I would need another half a bagel. So he would need 8.5 bagels to get 34 quarters. Oh, you can't see what I'm writing there, can you? So I would need 8.5 bagels to give me 34 quarters. I'm just going to check that. 34 quarters. How many lots of 4 can I make in my, out of 34? I can make 8 lots, and I'm going to have 2 quarters left over. We know that 2 quarters is also equivalent to 1 half, 8.5. Well done to me. Give yourself a pat on the back if you got that correct also. Well done. Brilliant. So today, what we're going to be doing is we're going to still be focusing on that skill of converting mixed numbers into improper fractions. So we've already done 2 whole days on converting improper fractions to mixed numbers. We swapped over yesterday doing mixed numbers into improper fractions, bit of a practice. And then today, what we're going to do is we are going to be using your Power Maths books today so that you can begin to start and think about mixed numbers and improper fractions, those relationships, and start to develop this skill of comparing and ordering them. Okay. So, as a little wake up then, we're just going to rewind our skills from yesterday. Okay, and I just want you to simply explain, how am I going to convert this whole, this mixed number, not a whole number, what's this Tyson talking about? This mixed number into an improper fraction without drawing it. Okay, so I want you to think about the calculation side of it now. So without drawing it, you can draw it once you've got an answer to check, but I would like you to really focus on the calculations and using your brain to try and remove your need for drawing these things So we're just going to take a step back and remove the drawings just for a minute. So I just want you to think about those calculations that you're going to have to do to work out what 5 3/4 would be as an improper fraction. Remember, improper fraction, numerator greater than your denominator. So just have a little go at that and see if you could think about those steps. Brilliant. So hopefully you've had a go at that. So all I'm going to do now is I'm just going to magically refer to our STEM sort of questions that we used in our learning the other day. Okay, so these were the questions that we used as our little bit of steps. So how many parts will make a whole? So have a look at this. How many parts will make a whole? Well, I know straight away that my denominator tells me how many parts make my whole. So I know that my answer to that question is 4. Okay. Next thing I need to think, how many holes do I have? Well, here I can see I have 5 holes. Okay, so I've got 5 holes, and each of those is going to have 4 parts. So each of those parts is going to have 4. One's going to have 4. 1, 2, 3, 4. That one's going to have 4. Okay, so how am I going to work out how many parts make those 5 holes? What's that calculation that I could do? So I've got 5 holes, and each of them have got 4 parts. So I've got 5 lots of, which we already know is times, 5 lots of 4. So I'm going to do 5 lots of 4, which I know straight away is 20, because I'm great at my multiplication and my times tables. Goodness me, my brain went to sleep then. So I know that 5 holes is the same as 20 quarters. Okay, because if I've got 20 of those quarters, I can make 5 holes. Wonderful. Is that it though? Am I done? No, because how many parts do I have all together? So now I can't ignore this mixed number because I know mixed numbers are wholes and fractions. Okay, so how many parts do I have all together? I've also got 3 quarters because they've not been able to make a whole. So then I'm going to have to add my 3 quarters, which is then going to give me my final answer of 23 quarters. Okay, so here, my little diagram, I need to see almost times those together. So I've got that many holes and that many parts in each hole. So I almost need to times them together and then add the ones that I've got, the numerator of the fraction. Okay, well done to you if you remember those steps and you got that right. Fantastic. So now we've rewound that, I want you to apply it into this question here. Okay, so every child should receive that fraction there, which is 1/4 of a fruit tart. So each child is going to receive 1/4 of the fruit tart. That's what Miss said. So how many children can have 1/4 of the fruit tart? So I need to take some information from the picture. So I've put some little questions here just to prompt your thinking. So how many holes do you have? How many slices are there then going to be? And could you show this using an improper fraction? Because that might help you to see how many children could then have 1/4. So this one you can use your drawings if you want to, but if you've got an even quicker, more efficient method, then you go ahead and you use that. So how many children can have 1/4 of the tart? That's question A. Okay. Once you've done question A, before you think about question B, which is how many children could have 1/8 of a fruit tart, I want you to put your explain it glasses on and think about your knowledge that you already know. So how is 1/8 different to 1/4? Because that's going to give you some tips on how you could use your answer from the first one to solve this second one. Okay, so what do you know about 1/8 and 1/4? Again, if you need to draw 1/4 and 1/8, draw it because it will really help you to see that relationship. Okay, once you've done that, could you use your pictorial representations to check your answers? So have a little go at those two for me. So how many children can have 1/4 of a fruit tart? You need to have a look carefully to get that information in the picture. And how many children could have 1/8 of a fruit tart? And once you've done that, once you've thought about the relationship, could you say how you might have used that answer from A to solve question B? That's a little bit of an extra challenge if you think, yeah, I've got this precise and I know what I'm doing. Wonderful. So pause this and have a little go, and come on back when you're ready. Brilliant. So hopefully you've had a little go at this now in your books. So let's get going then. So how many children can have a quarter of a fruit tart? So the first thing I'm going to do is I'm going to look in this picture because I need to know what fruit tarts I'm working with here. So I can see here that I've got one fruit tart. So I'm going to draw it. I've got 2 fruit tarts. I've got 3 fruit tarts. I've got 4 fruit tarts. And then on that plate there, that little boy is holding, I am going to take a guess that to me, I can't be certain, but I'm going to go with, because of the question, that is 1 quarter. Okay? So what is this mixed number that I'm showing here? I've got 1, 2, 3, I've got 4 wholes and 1 quarter. That is the mixed number that I'm working with. Okay, so now I need to work out how many children can have a quarter. So I need to now know how many quarters I have in 4 and 1 quarter. So I can use these drawings to help me, okay? But I'm going to try and use my method that we've just practiced, and then I'm going to use this picture to check my answer. Okay, so I know that 4 and 1 quarter, shrub these out and we'll get back to them. So I know that my mixed number, I have got 4 whole tarts and 1 quarter. Okay, so each of those whole tarts are going to have how many parts? They're going to have 4 parts, aren't they? So my first number sentence that I'm going to do is 4 lots of 4, which is going to give me how many parts? Because remember, these 4 parts, these 4 wholes each have 4 parts. So 4 quarters, 8 quarters, 12 quarters, 16. It's 4 lots of 4, square number, is 16. Okay, so I know that 16 quarters is the same as 4 wholes, because I've just worked that out. Okay, am I finished though? What else do I need to also do to get my final how many quarters I've got in total? Because this is just the 4 wholes. I also have this extra slice that boy's got on that plate. So I now need to do 16 quarters plus that 1 quarter that I've also got. So how many quarters do I have in total? I have 17 quarters. So fingers crossed, keep that number in your head. 17. Oh, all right, and that's a mixed number. I'm not doing a mixed number, Miss Lyson, I'm doing. So let's have a look. There's what we've just worked out. So 4 and a quarter is equal to 17 quarters. I'm now going to go back to my drawing to see if I was correct. So remember, we had 4 wholes, and then we had that 1 quarter on the plate. So remember, if it's a whole, how many parts make up the whole, and cutting it into quarters? So that pie will give me 1, 2, 3, 4. That pie will give me 1, 2, 3, 4. That pie will give me 1, 2, 3, 4. And that tart will give me 1, 2, 3, 4. So I've got 4, I've got 4, 4, 4, and 1. So let's add them together. I know that 4 and 4 is 8. I know that 4 add 4 is 8. 8 add 8 is 16. And I've got this extra 1, which is, oh, can't see that, it's gone off, 17. So I've got 17 quarters, which is the correct answer that we got. I'm just going to count them now just to check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Well done to you if you got that right. So let's just go back to that question then. So how many children can have 1 quarter of a fruit tart? So how many children can have a quarter? I've got 17 quarters. So how many children can have a tart? A slice of the tart? 17 children. Lucky, lucky them. Okay, so now we're going to go to question B. So remember, before you solve this, I asked you to think about the knowledge between a quarter and an eighth. So I'm going to use my same whole. I'm going to show a quarter, and I'm going to show eighths. This is the denominator of 4. This is the denominator. 1, 2, 3, 4, 5, 6, 7, 8. What has happened to my denominators there? So when we were finding equivalent fractions, what is the relationship here between my 4 denominator and my 8? I have got twice as many parts, haven't I? I'm just going to keep that in mind. Twice as many parts. So how many children can have an 1/8 of a tart? I've got twice as many. So what I'm effectively doing here is I'm changing my denominator from quarters to 8. So here I've got twice as many parts. So to get an equivalent fraction, remember whatever we've done to the bottom, whatever has happened to the bottom, also has to happen to the top. So this might have been a really, really quick, efficient method that you use. So well done to you if you use this. So I'm going to use this method, but then I'm going to revert back to my converting from mixed numbers to improper fractions to then check if we are correct. So I now know that I need to do 17 times 2. Now I know it's double, but I'm just going to use my short division just to double check and rewind that skill because I've not done any short division in a while. So 7 times by 2, 7 lots of 2 is 14. 1 lot of 2 is 2 plus 1 more, 34. So if my knowledge of equivalent fractions is correct, 4 1/4 should be equal to 34/8. Let's have a look. Let's use my method. Where's my rubber gone? Let's now use my mixed converting method to see how we got on. Okay, so I've still got 4 and I've got 1/4. Now, the problem that I've got here is I am still thinking about this in quarters. So now I haven't got quarters, I've now got 8. So I'm going to ignore this number here and I'm simply just going to draw this one. Okay, so there's my 4 holes and there's my 1/4 that I've got. Okay, so I'm now going to cut each of these into 8ths. But I've got 1/4 here. What is the relationship between quarters? How many 8ths will you get from 1/4? How many 8ths will we get? How many 8ths can I make with 1/4? Use your knowledge of I've got 2 times as many parts. Do the same to the top because I still need the same amount of parts to make them equivalent. So I need to also times that by 2, which is 2/8. So I can actually chop that one in half. Okay, so let's count them, shall we? I'm going to use my 8 times table because I'm good at my 8 times table now. So I've got 8 there, I've got 16, 24, 32. So 4 holes equals 32/8. But then I also need to add these extra 2 parts. So 32/8 plus 2/8 equals 34/8. So I've just proven there using my pictorial representation that we were correct, and actually my knowledge of equivalent fractions of 4 quarters and 8 helped me to solve that in a much more efficient method than having to do all of this. So well done to you if you managed to get those right. So that second one took a lot more of your brain power. So well done if you got that right. If you didn't quite get it right, can you see what mistakes you got, mistakes you made? And is it something that you can remember and make a note of before you carry on with your learning today? Well done. Okay, so now you've had a little chance to rewind all of our skills on converting from mixed numbers to improper fractions. I just want you to have a little go at these ones here. Okay, so you can see they've given you some mixed numbers and they simply want you to convert them into improper fractions. Okay, so just remember make a note of your denominator. Okay, because that's really important. Your denominator is not going to change because your parts are still staying at same size. okay? We're not finding equivalent ones. We're not looking for smaller parts or larger parts. We are still keeping those many parts make my wholes, okay? So this mixed number will have the denominator of what? This number will still have the same denominator of what? This one will have the denominator of what? This one will have the denominator of what? Okay, so simply want you to do those 4 for me using whatever method you are more confident with. But again, thinking about your efficiency. So remember, using our knowledge of timetables and our faster methods are going to get you to your answers quicker. Okay, and there's probably less chance of you getting it wrong if you're trying to draw out lots of different wholes, lots of different parts. Okay, but again, whatever method you are confident with, I'm not forcing you to use any. I'm just saying which one is the most efficient. Okay, so have a go at those at getting your equivalent fractions. Once you've had a go at that, if you think I want to push myself a little bit further today, I want you to have a look at this here. Okay, so somebody is trying to make and trying to start to notice the different patterns that they may see when trying to solve this mixed number into an improper fraction here. So simply test a few numbers into your hypothesis, testing your hypothesis to see if you can work out what's going to happen here. Once you've done it, can you explain what happens to the triangle when you increase the star by 1 each time? Okay. So those 4 is the minimum that I want you just to have a go at and have a practice at. This one here is if you think I'm ready for a bit of a challenge, Miss Tyson, I want to check my understanding, I want to test my brain. Okay, so let's have a little look here then. I'm going to draw on here just so you can see it a little bit clearer, because my camera's getting a little bit fuzzy. So first thing then, 1 and 3/8 is equal to what? Okay, now I know as an improper fraction straight away that I already know what my denominator is going to be, because remember, it isn't changing. Okay, it's not changing sizes of my parts. I'm just counting how many parts I've got. So I know it's definitely going to be an 8. So how many parts make up my whole? I'm just going through those questions, those steps that we've just done. So how many parts make up a whole if I'm thinking about my 8? So 1 is equal to 8/8. Okay, now I have got one. I've got one lot of 8/8. Okay, so how many pieces make up that one whole? 8, because I've done 1 times by 8. Okay, then I've not quite finished because I've also got the fraction 3/8. So what do I need to do with those 2? I need to add them together to get my total. So 8, 9, 10, 11. I've got 11/8. So I know that 1 and 3/8 is equivalent to 11/8, because I can make one lot, one whole. So 8 pieces will make one whole, 9, 10, 11, I've got 3 left. Well done to you if you got that right. Okay, next one then, let's change colour so we can see. So this one now, I've got 2 1/3. So 1 is equal to how many thirds? 3/3. But I have now got 2 of them. So I need to do 2 lots of wholes. 2 wholes is going to be equal to 2 lots of 3, which is going to be how many? It's going to be 6/3, because I'm going to need 3 to make that whole and 3 to make that whole. So I'm doing 2 lots of 3. Then I also need to add my extra ones that I've got in my fractions, which is 1/3. So if I've got 6/3 and then I add another third, how many thirds do I have? I have 7/3. So well done to you if you got that one right. Next one then, denominator. What do I know straight away that my denominator is going to be? Because remember, we're not changing any sizes of parts, we're just counting how many parts we have. So I know that I'm now working in halves. I'm working in halves, okay? So 1 is equal to how many halves? So how many halves do I need to make a whole? Thinking about my bagel, you need 2 halves, okay? How many holes do I have? I've got 3 holes now, so I'm going to have 3 lots of 2. So 3 times by 2 equals 6. So I know that 3 wholes is the same as 6 halves. So if I've got those 6 halves, those 2 come together to make 1, those 2 come together and make 1, those 2 come together and make 1. Okay, 1, 2, 3. But then I'm not finished because I've also got my half that I also need to include in my total. So I now need to do 6 halves, 1 more half, which is 7 halves. And I know my answer is equivalent to 7 halves. Fantastic. And this last one then, some larger numbers here, some larger numbers. So if you follow this method, where's my rubber? Let me just, so I've got some space. If you follow the method, you should still be able to apply, oops, didn't mean to put that out. You should still be able to apply this method, even though our numbers are getting a little bit larger and we're getting more and more parts, okay? If you still follow these exact same steps, you will still be able to get the correct answer, okay? How do I get my rubber off? Put that back in there, the 8s. Okay, let's go for, let's do a blue. Okay, so 4 and 19/20. So 1 whole is equal to how many 20ths? So how many of those 20ths do I need to make a whole? I know if my numerator and my denominator are the same, it is equal to a whole. Okay, so 20/20 will give me 1 whole, but I've not got 1 whole. How many wholes do I have? I've got 4 wholes. So what am I going to have to do? I've got 4 lots of 20/20. So I'm going to have to do 4 times by 20, which is 20, 40, 60, 80. Goodness me. So I know to make those 4 wholes, I need 80/20. Okay, because then 20 of them will group together to make 1, 20 will make another one, 20 will make another one, 20 will make another one. Okay, so 80/20 will give me my 4 wholes, but I've not finished yet because I've still got that fraction that's not quite a whole yet. So what do I now need to do? I need to add my 4 wholes, which is 80/20, and my fraction that I still have in fraction form because it's not made a whole yet, which is 19/20. Goodness me. I'm going to add them together. 80 plus 10, this is how I would do it, is 90, and then I've got 9 ones. So I have got 99/20. So you can see there that no matter how big, how many parts, the method still works. So still ask yourselves those same questions. Okay, there is no difference from doing 1 whole to doing 4 wholes. There's no difference from doing 3 parts to doing 8 denominators to having your denominator being 1,000. Okay, if you follow those steps, it will still get you to your answer. So well done to you if you got those 4 questions correct. Okay, so with this Explain It, rather than me taking up lots of time on this video, telling you and talking you through all your answers, I simply want you to label your Explain It on your book and make sure you send pictures to us on your portfolio so we can see what relationships you are noticing between these numbers. So well done to you if you got onto that and you are managing to send us if you managed to send us your ideas around it. Okay, so what we're going to focus on today then is we're going to go into our Power Maths books and just show how amazing you are at now converting your mixed numbers, sorry, into your improper fraction. So you can see question 1 is using lots of pictorial representations to help you to get to your answer. So you need to look, they've given you the whole on the first one. They want you to tell you how many parts, how many thirds you have. Excuse me. This next one here, they've not given you your denominator, so you need to then think about, right, what is my denominator? How many parts make up my whole? Remember, and then tell me the improper fraction. This next one here, they've used a bit of a bar model here. You've got one whole, one whole, one whole, one whole, one whole, one whole, then you've got 1/5, 1/5, 1/5. So I already know what that denominator is going to be. How many wholes do you have? And then can you convert it? Okay, so don't fall into that trap. Just be careful with that one. This one here, can you match each of the mixed numbers into the improper fraction? So if you want to do a little bit of working out here, to then match them up, that's absolutely fine, however you want to do it. Or if you can already see relationships between these, so you might want to look at your denominator, might give you a bit of a clue. This one here, they've just simply given you the a number line to see this one, okay, and you see that they split their number line here into halves. This one is already split into thirds. This one is already split into how many? That's going to help you to get your denominator. So this is where it's starting to get a little bit more tricky. So just applying your method in lots of different ways, okay? Remember, if it does get a little bit too tricky, just have a pause and have a focus just on that method. Okay, think about what do you already know, what information is going to help you. Okay, then you've simply got the mixed number that they want you to convert. So using whatever method you would like to. If you need to do any extra working out and you've got no space, just do it into your blue box. Then this question here is going into a word problem. So pretty similar to what I did with Mr. Armstrong's little problem this morning. And so a waiter has 3.5 litres of juice. A glass holds 1/4 of a litre. How many glasses can fill the water? So you've got a bit of a two-step problem there, because my glass only holds 1/4, but my measurement is in halves. So have a little think about that. How are you going to use your equivalent fraction knowledge? And how are you going to use this knowledge from today? Brilliant. So when you've done that, as always, you can get onto your challenge. So this one here, they like to do this a lot when we were doing our division and our multiplication questions. So it was almost thinking about those missing numbers. So can you use your knowledge to revert, to work out what those missing parts are going to be? Okay, so think about what is missing, what knowledge do I have? And then there is a question 6. Sorry, I completely missed question 6, went straight to question 7. How many 8-kilogram weights would we need to balance this box? Okay, so it's just putting it back into a real life context. So how many of these weights do I need to then balance out my equation? Because remember, if my weights are balanced, they are the same, they are equal. Okay. And as always, then you have got your explain it. So this is asking you now to draw a diagram to show why 2 4/5 is equal to 14/5. Okay, so think about how you could draw that model to show you that those two are equivalent. Well done for all of your hard work this week. I'm hoping that you have absolutely smashed all of your work in. Hope that you will smash your work today, and we can't wait to see all of the great work that you send across on your portfolios. I will see you all again soon for some more maths. Goodbye.